Welcome to clickmeproject.com. Let us discuss about discriminating DDoS attacks from flash crowds using flow correlation coefficient. Here is the abstract of our project. Distributed denial of services. Distributed analysis attacks where the multiple compromised systems is used to target a single system, just cause a denial of services DDoS attacks. The victims are going to use the botnets for these attacks. In this paper, we present a novel flow similarity based approach to discriminate DDoS attacks from flash crowds, which remains an open problem to date. Distributed denial of service attacks pose a critical threat to the internet, motivated by the huge financial rewards such as renting out of their botnets for attacks for collecting sensitive information for malicious purposes. Hackers are encouraged to organize the botnets to commit these crimes. One powerful strategy for attackers is to simulate the traffic patterns of flash crowds to fly under the radar. This is referred to as the flash crowd attacks. And we propose a flash crowd attacks detection method using flow correlation coefficients. We aim to protect potential victims from flash crowd attacks within a community network. A community or a ISP or networks often operates with the same internet service provider domain or the virtual network of different entities. It's all cooperating with one another. The community network benefits the defenses of DDoS attacks in wide range in a cooperative way. This is hard to achieve in the realm of the internet, where anarchy is entirely the principle. We first establish the model of DDoS attack detection in a community networks. We just identify the multiple paths for the same precursors. From that, the comparisons among the proposed methods previous can be online supporting materials, which produces the effective results for detecting the online DDoS attacks. Here is the data flow diagram of our project. Initially, we are going to import our data set which contains the specific attributes denotes the URLs, which contains the source. So the request come from the source and on the date and time, as well as the URL just denotes the destinations, as well as then a number of bytes transferred for this request, and finally the request code from replays from the internet service provider just will be stored in the data sets, which is used to identify the distinct URLs for the same destinations. Then identification of highest request. In this flow, we just going to identify the requests highest requests forwarded to the same destinations within a 1 minute can be taken. Just from that requests we identify the distinct flow, the multiple flow, how the sender just send the data send the requests from the distances flow can be identified. For the distinct flow, we identify the number of requests for the distinct flow of the same destinations is URLs. Then we are just going to calculate the explanation values for the distances flow for all the flow based on this formula specified in the as flow of strength is. Then just we are going to based on that expectation we are going to compute just the flow fingerprint values for the distances flow for the same destinations as we identified from the data sets. From that we are just going to calculate the correlation coefficient value, how the two flows are correlated, just how percentage we also identify just to identify the to find out the DDoS attacks as percentages. From that values we are going to fix the threshold values. If the threshold values are greater than the coefficient value, just we are going to identify the mean value for the two distances flows. From that flow we are going to confirm the DDoS attack confirmations. Here is the running procedure of our project. Just we are going to insert the load of data sets which contains the number of distinct URLs as we mentioned earlier with specific attributes to identify the DDoS attacks. Data set can be viewed just we can view the number of multiple attributes scavengers. It is source IP addresses which the requests came from. This is date and time just as per the request is taken just for the process as per 1 minute just, and then we take the destination URL as jabong.com, which this is a replay code from the internet service providers. These are the number of bytes transferred for the same requests from the users. Next, we are just going to count the number of requests and number of distinct replaces based on that requests and user. As we are going to identify the distinct URL requests for the same destinations. These are the distinct URL requests with the number of requests can be identified. From the the Jabang it shows us as highest request as 24. Just we are going to identify the subspecies flow for that from the available just distinct URL request. Next, we are going to identify the distinct flows. For that, the three different flows are taken. For the three different flows, the number of packets for the same length flow can be taken as part of the process. So, the first two flows can be identified and taken for the process. Just we are going to compute the packet computation. Just the number of packets received for the distance flows as per the request came from 10. For the same requests, the expectation values can be computed just based on the respected formulas as we mentioned, as which is used to denote the flow strength. Just we are going to calculate the flow fingerprint. As we are going to analyze the two flow fingerprint, the first flow fingerprint can be calculated just like this. The second flow fingerprint is final. We are going to calculate the coefficient value based on this. Just next we are going to calculate the correlation coefficient value for the two distances URLs for the same destination. Just the similarities of the flow can be computed. Just based on this, we are just going to identify the threshold values as by means of identifying the mean value of all the values of similarities. From that, the data will be calculated as 33%. 33% of the requests can be taken just for the data set access can be identified. So we can confirm the conclusions of the flow correlation coefficient is 1. There is no noise and no delay between the two attack flows. The background traffic noise contributes the decrease of the flow correlation coefficient values. From that, yes, we can identify the legitimate flows as the meaning of conditions with the DDoS spreading attacks. It is an efficient way of using the correlation coefficient values is very limited when compared to the noise-free cases.